Hello dear students, today we'll see the window comparator experiment, that is design window comparator for given UTP and LTP values by using IC741 Opamp, and simulate the same thing by using a Pspice simulation software. UTP is nothing but upper threshold point, LTP nothing but lower threshold point. So this is the circuit diagram for that. Before I go to creation and implementation of this circuit diagram, we will just see what is window comparator. Window comparator detect input voltage level that are within a specific range or a window. Okay. If the signal is within the window, the output will be high, else the output will be low. What does it mean? So you just see the output of this. I'll show you the output first. You'll understand better what the window comparator will do. So this is the output of window comparator. So here you can see the red waveform, right? This is the sinusoidal waveform and this is the input waveform. This waveform. Okay, the green color waveform, whatever you are saying, that is the output waveform. So here I have taken the UTP 4 volt and the LTP is minus 4 volt. Now, whatever the waveform you're getting within this range, for that we are getting the high output. For example, see here 0, 2, 4, 6, 8 and 10. I have taken amplitude as a 10 volt. So at this point 4, at 4, okay, I'm getting high. See here, I'm getting high. So again, it will become low below my UTP. Okay, I'll get the low output. So it will be remain low until minus 4. So this is minus 2, here minus 4, minus 6, here minus 4. At this place again it going from 0 to high. It will remain high until that particular window. Again, minus 3, minus 2, minus 1, 0. See, it went back to 0. It will remain 0 until the 4. Okay. So this is the window comparator. If the signal is within a window, whatever UTP and LTP value we have given, if the signal is within that, we will get the high output. Okay. If the signal is out of that range, we will get the low output. That is the window comparator. Now we will see the circuit diagram. So here this is the circuit diagram of window comparator. We need two Opamp operational amplifier IC 741 IC. We need one V side to generate the sinusoidal waveform, that is input waveform, and we need two diodes and one resistor and a VDC to supply plus 12 volt and the UTP value and the LTP value. So I'll construct this by using the Pspice software. I have already explained to people how to install Pspice software. Please watch that video and to configure, to do the settings, initial settings. Just open the Capture Light Edition, that is Pspice software. Go to go to File, New Project. Select analog or mixed AD, give some name. I'll give window comparator. Create a blank project. Now this is the area where you have to place the component. Go to place. In the part, you will get all the libraries. Under each library, you will get so many components. So I'll select eval library. I'll type UA741. How to add the libraries, everything I have explained in the installation of Pspice software. Okay, then click OK. We want to the Opamp ICs. I'll place it wherever I want. Again, I'll go to place part. This time I will take diode D1N4002. I'll place one diode here, one diode somewhere here, right click end mode. Then again I'll go to place part. I need one resistor. I'll select analog library. I'll type R, rotate it, place here. Then I need one V sign to generate the sinusoidal waveform. I'll go to analog. Source. I'll just type here V sign. Select this, place here. Click end mode. Okay, after placing the component, you have to connect it by taking the place wire. There is a connection between pin number 2 and this V sign, and pin number 3 is connected to pin number 2. Until you see the red dot, you have to stop it. No, you cannot go further like this. Okay, whenever you see this red dot, you have to stop it and you have to connect from this square box to another square box. There is a connection between diode and pin number 6. Pin number 6 to diode, and this diode is connected to one more diode, and This resistor is connected to this, and I'll just drag and I'll drop somewhere here so that easily I can connect my VDC. Here also I'll drag and I'll leave. Drag and I'll leave. Here also, if you want, you can do it so that easily we can connect, change the values. That look neatly. Okay, right click end mode. Done. My connection is over. Now I'll connect VDC. You just see the circuit diagram. Connection I have given. Now this VDC source we have to connect to supply plus 12 volt, minus 12 volt, UTP value, LTP value. For that, I'll go to place part in the source. I'll take VDC. Student, remember this is very important. You have to connect the positive end to pin number 7, negative end to pin number 4. This is very, very important. If you vice versa, if you reverse here, if you connect the positive end to pin number 4, negative to pin number 7, that is minus 12 volt to pin number 7 plus 12 volt to pin number 4, it'll IC will burn, it will damage the circuit, the breadboard, other components. So pin number 7 is positive end is connected to pin number 7, negative connected to pin number 4. Here also pin number 4. Then rotate it. Positive should be connected to pin number 3. Again, positive should be connected to pin number 2 for UTP. So this is for LTP, this is for UTP, and this is to supply the plus 12 volt, minus 12 volt for our Opamp IC. Now after that, give ground, select 0, select source, select 0, click OK. One ground you can connect here, one you have to connect here, one to this negative end, one to this negative end. Here you have to connect for this negative, and here. Okay. 7 grounds you have to connect it. Yeah, one more here. Right click end mode. Then after connecting the ground, change the value. This is let it be 1K, and you have to change the value here. That is minus 12 volt. Why I'm not giving minus here? Because I have connected the negative end. So by default it will become minus 12 only. Here also plus 12 volt I'm giving. Here also 12 volt. 12 volt. Here UTP value I'll take 4. Whatever you want, you can take it. Minus 3, minus 2, 2 to 4, whatever you want, you can take it. I'm taking sorry, here minus 4. LTP is minus 4, UTP is a plus 4. This is LTP and this is UTP. Okay, we want sine wave, no? What type of sine wave you want? Amplitude, what is the amplitude? I'll give 10 volt. You can give anything. Whatever you want, you can give it. Frequency, I'll give as 50 hertz. V off, I'll give 0 volt. Okay. Now ground we have connected, values we have changed, connection is done, circuit diagram is ready. For that, after that, what we have to do? Go to the Pspice new simulation profile. Click new simulation profile, give some name here, click create. Okay. Once you click create, you have to give the value of the run to time and step size. Yeah, it's opening here. Here is the run to time. I'll give 100 millisecond. You can change it based on the requirement. 0.01 millisecond. I am giving the maximum step size. Click apply. Okay. Okay. So after that, I'll open the circuit diagram again. Now I'll connect the voltage level marker. If you want to see the output, okay, then you have to connect at pin number 6. If you want to see the input, this is the device which is generating the input. No, for me V sine, it is giving me the sinusoidal waveform. If you want to see that, you have to connect at this point. If you don't want the input, you can remove this voltage level marker. Then save it, execute it. Okay. Okay, student, this is the exact output, and don't worry. See here, sometime you'll not get the output because of the connections, or you might have missed some ground connection, or you might have given some wrong the values. Okay, because of that also you will not get the output. Okay, if you don't get the output, don't become panic. You just check the connections properly, check the values. Then once again, you go to Pspice, create new simulation profile, give the values required, step size and read to time, and you can execute it. Okay, so I have connected two voltage level marker. One is for input waveform, another is for output waveform. So that's why I'm able to see both input and output together. How to separate this? How to separate an input and output? Okay, I have explained in my previous video. That is Smith trigger. You can watch that video to separate the input and output waveform. Okay, so this is the exact output. Now see here, this is 0 to 4. I have given 4 as a UTP, right? So at this point, see, till here, my waveform, the output is low. See, this output is low. Whenever it reaches the point, that is 4 volt, this from low to high it's going, and it will remain high until 4. Okay, below that, now here see this waveform, here it is 4, again it's coming 3 2, at this point from high to low we are getting here, and it will remain low till this point, and again once it reaches -4, again it's going low to high, and it will remain high till -4. Okay, student, this is the window comparator. I hope you understood this. Please follow these steps, easily you can execute. Thank you, thanks for watching. Thank you so much.